So, a quick review from yesterday. Let's say we had two complex numbers, 5 plus 12i. If we multiply those, what we traditionally would do is FOIL those out. So, I would FOIL these, get 15, I would get plus 36i, I would get 20i, and then I would get 48i squared. Alright. The result here would be negative 33 plus 56i. That's how we originally did it earlier in the school year, but we learned yesterday that actually what we could do is we could find the magnitude of each of these, and then the angle of each of these, and use that to find the magnitude and angle of our new complex number, and this was called polar form. In the book it was also called trigonometric form because you used cosine and sine. So I know that 3 squared plus 4 squared equals 5 squared, and 5 squared plus 12 squared equals 13 squared. So I know automatically that 5 times 13 is going to be the answer to the magnitude of my result. And indeed, if I go to the calculator and I do the square root of 33 squared plus 50, I actually do get 65, which is 5 squared plus 13 squared, square rooted. And then, additionally, if I do tan inverse to find angles, here are the angles that I get. I get 53 degrees, about, and then I get about 67 degrees. And so, if I were to do tan inverse here, I would expect adding that up to be 120 degrees. Okay, so if I tan inverse 56 all over negative 33, well, it turns out what I get is negative 59 degrees. So about negative 60 degrees. But remember that this result here is going to be back 33 up 56, and tan inverse always gives us answers on the right side of the unit circle. So negative 59 degrees, we have to add 180 degrees to get the actual angle, which would be about 120. It'd be 121, but we're doing some rounding here. Okay, so which one's easier? Actually, probably the foiling for this. So why did we learn this? This is where de Moivre's theorem comes in. Here we have a couple complex numbers on the plane. Here is my first number, 1, 0, and I'm going to be multiplying by 1 plus I every time. That's this number up here. So 1 times 1 plus I will be this, times 1 plus I again will be this. And you can see it's starting to spiral out, and actually down here we have 6. Okay, and I have created a slider here. This slider is going to represent our power. So when I slide n over to 1, that just represents 1 plus I to the first power. If I slide it over to 2, that's going to be 1 plus I squared. So times 1 plus I times plus 1i. And you'll notice as I keep increasing the power here, this thing starts to spiral outwards. So what's happening here? Well, 1 plus I has a certain number of degrees and a certain magnitude. The magnitude here would be 1 squared plus 1 squared, square rooted, so this guy is square root of 2. And it has a certain angle, it's 45 degrees. So when I do it once, when I just have one of them, I am square root of 2 out, and I'm at 45 degrees. So if I were to draw a line straight from here to there, 45 degrees. Same thing with multiplication. If I multiply that by itself, I would do 45 plus 45, and since my magnitude is root 2, it would be root 2 times root 2, which is 2. And if I keep going here, I'm going to multiply whatever this was by root 2 again, so this should be 2 root 2 with another 45 degrees. And then another root 2 times root 2, it's going to be 4 out, but it's going to be rotated 180 degrees. And so what this does is, de Moivre's theorem is basically saying that if you multiply by the same thing over and over, you're actually just adding on a certain number of angles, and you're multiplying or powering up the magnitude every step. So let's actually write this out. Let's make this an example. Example. If I end up with 1 plus I, and I want the 7th power, the last thing I want to do is to write 1 plus I 7 times and then try to FOIL out that many times. So what I do instead is I realize my magnitude here is going to be the square root of 2. 1 squared plus 1 squared square rooted. And my angle, normally you'd have to do like tan inverse, but in this case it's going to be 45 degrees because that is the geometry of the situation. Now, what I know is that if I do 1 plus I squared, that's going to mean that I'm going to have the magnitude squared, and I'm going to have double the angle. So I would write this out, cosine of 45 degrees times 2 plus I sine of 45 degrees plus times 2. So really what this comes out to be is 2 cosine of 90 plus I sine of 90. But that was just one power. I could do much more than that, and it's way easier to do powers instead of FOILing it out 7 times. So for the actual answer, I would take the magnitude square root of 2, raise it to the 7th power, and I would do cosine of 45 times 7 degrees plus I sine of 7 times 45 degrees. Okay, so what is the square root of 2 times 7? Well, there would be 7 root 2's, and for every root 2, you would get a 2, so that's 2 times 2 times 2 times root 2. I get 8 root 2 as my magnitude, and 7 times 45 is 315, so I would have cosine of 315 plus I sine of 315. Now this we call trigonometric form or polar form. If I wanted a plus b I would take this and distribute it, and a lot of the times it's okay to just give a decimal number, so that's what I'm going to do here. I'm going to do 8 root 2 times cosine of 315. I get 8 there, and it's a unit circle number, so that makes sense that it comes out nicely. And then I'm going to do the same thing with sine of that angle. So sine, that comes out to be negative 8i. So that right there is my answer, and I didn't have to FOIL out a single thing. So you should give this a shot. So remember that if you're doing a plus bi to a power, the way we do de Moivre's theorem is you're going to take the magnitude to the nth power, and you're going to do cosine of the angle times n plus I sine of the angle times n. But you have to know the magnitude and you have to go find the angle, so you might have to do that first. Give it a try. For this number, take this and raise it to the 10th power. You should pause the video, and then when you are done or stuck, continue. Alright, so first we're going to find the magnitude. That would be the square root of 1 squared plus root 3 squared, which turns out to be square root of 4, which is 2. Theta here, well, it's going to be over 1 and up root 3, which is that right there. So the theta here we're going to have to use tan inverse to find. But using my unit circle, where is the tangent root 3? That's going to be at 60 degrees. So my answer for this, I can raise 2 to the 10th power, and then I would write cosine of. Now my angle is 60 degrees, but I'm going to multiply by 10. Alright, now that is an angle of 600 degrees actually. So we should shorten that, take out the multiple circles that we would have to revolve around to get there, And if we take 360 out of that, we get 240. So my final answer here would be 2 root 10, or 2 to the power of 10 cosine of 240 sine. There we go. If we had asked for a plus bi, all we would need to do is take the magnitude and multiply it in.